So last week we talked about normal distributions. And when we did normal distributions, we talked about the normal curve and how you have the mean and you have 1 standard deviation, 2 standard deviation, 3 standard deviation. You have -1 standard deviation, -2, and -3 standard deviations. And these basically are what we call z-scores. So the z-score represents the number of standard deviations a given value falls from the mean. And we used X bar last week. One of our homework assignments and in our calculator, it uses this symbol here, okay? If the z-score is positive, it is above or to the right of the mean. If the z-score is negative, it is below or to the left of the mean. And we use the mean to help us to compare two scores from different normal distributions or find the place it is on the distribution. So if we want to find a z-score, we use this formula right here, which basically says the number we have minus the mean divided by the standard deviation. Okay. Now, there's a couple of other things they can ask us to do when we're talking about z-scores. If we want the percent and we have the z, or if we want the percent and we have the number, we would do second vars normal CDF, okay? And what this normal CDF is, it accumulates the distribution, so it adds up. So last time we might have said, what's this percentage between here and here? And we would add up the percentages that were in there in our normal curve, right? And so that's what this does. Normal CDF accumulates or adds up the numbers between each of these things. And so we have to have a lower number and upper number, a mean and a standard deviation. So if we have two numbers, that's no problem. But if it says above, what's the amount above a number? Then we're going to use 999 for the upper value. Okay, so like if it said, I want the percentage from above this amount, so from here up, then we would say from here to 999. And if it said if below the number, then we would say down here. So up here is 999, and down here we would say -999. So we would use -999 for our lower number. Okay. Now, if we want the z or we want the number and we have the percentage, this is the opposite of what we've been doing. So we would do second vars, inverse norm, so the inverse, the opposite, and we would put the percent as a decimal in, and then it asks us for the mean and the standard deviation. If we want the actual number, then we put the actual numbers in for mean and standard deviation. If we just want the z, then we put in 0 and 1, because 0 is our mean here, and our standard deviation is 1 here, so that we use 0 and 1 here. One thing you have to know about inverse norm is that these come from below, okay? They add up, the percentages come from below. So like if I said, example, I wanted the top 20%, well, in my normal curve, if this is the top 20%, the inverse norm comes from below. So if I put in inverse norm 0.20, then that wouldn't work because that would give me down here. I really need to do the inverse norm of 80%. So for this particular problem, I would say the inverse norm of 80%. and 0 and 1 or whatever it is. Okay. And so that's what I would need to do. Okay. So that's what we would need. Those are all the notes that I can think of that you need for this. So let's do some examples and look at some homework problems. So it says Lewis earned 75 on his biology midterm, and then he earned 71 on his history midterm. And his biology midterm had a mean score of 80 and a standard deviation of 4, where his history midterm had a mean score of 73 and a standard deviation of 3. Okay. So we want to be able to compare these numbers and being able to compare them similarly, right? Right now, they're not similar. They're not the same kind of scores. And so in order to make them so that I say they normalize, we want to be able to find their z-scores. And so what we do is when we find their z-scores, then we can compare the z-scores and see that kind of puts them on a normal thing here. So the biology z is the number we have minus the mean divided by the standard deviation. And I am going to pause right here. All right, so we would say 75 minus 80, find the answer and divide by 4. So we get negative 1.25 as our z here. And for history, we get 71 minus 73 divided by 3. And so 71 minus 73 divided by 3. Uh-oh. I don't want to put that in right there. Otherwise, it's not going to come out right. We want to hit enter first. So negative 0.67. Now, on our curve here, this is 0, negative 1, negative 2. Okay? So on our curve, our history score shows about right here. And our biology score is about right here. Okay? So one's right here, one's right here. Which one's better? Now we can compare them because they're on the same curve here. And so we say that the history grade is better. It looks like his biology grade would be better because it's a higher score. He got a 75 versus a 71. But as we norm these, the history grade is better because his z-score is higher. Okay? So basically what this says is he got a better grade in biology, but more people got better grades than he did. Where in history, he didn't get as great a grade, but that means more people got worse grades than he did, okay? So that means history was his better score. So let's look at SATs and ACTs. So this is the SAT scored 1240 with a mean of 1081 and a standard deviation of 176. And the ACT was a 27 with a mean of 18, standard deviation of 6. So let's find the Z's for these. So the SAT definitely can't compare these because these scores aren't even the same, right? We got hundreds or thousands and we got 20s and stuff. You can't even compare these. This is really comparing apples to oranges. So we get 1240 minus 1081 divided by 176. So 1240 minus 1081 divided by 176 is 0.90. And then his ACT score So his ACTZ is 27 minus 18 divided by 6. So 27 minus 18 divided by 6 is 1.5. So if I was looking on my curve, so here's 1, here's 2, here's my mean. My ACT score is right in here, right? 1.5. So that's my ACT. And my SAT score is like right here. So obviously my ACT is better, okay? Because my Z-score is higher. Questions is what we would go from there. Now, the other thing that they can ask us about is they could say, so this question says class of 217 participants in softball throw. The mean is 173 and the standard deviation is 31. What percentage of students was able to throw the ball? But okay, so on our normal task, we said what percent is between here and here, right? And so when we do questions that look like our normal task, we want to do what's called a normal CDF, okay? And the normal CDF asks us the lower bound and the upper bound. So we have our normal bound and our upper bound, our lower bound and our upper bound. That's our lower bound and our upper bound. And then it's going to ask us what's our mean and what's our standard deviation. Okay, so I want you to write what you would put in your calculator. So this is my lower, this is my upper, this is my mean, this is my standard deviation. Okay, and any question that looks like your task questions, when it's asking you about percentages between here and there, above here or below there, that would be a normal CDF. Okay, so we go to our calculator, we do second right here VARS, and we do number 2 normal CDF. And so we're doing from 151 to 180. Our mean here is 173, and our standard deviation is 31. And so we just put that in, and you'll see that we get this decimal. Well, our calculator, when we did these normal tasks, we got a percent, right? Well, our calculator can't write percents. So it gives us the decimal value. Well, we have to turn that back to a percent. So that's 35%. It says what percent of students could throw farther than 200 feet? So if it was from here, 200 feet and farther, right? That means I need to go to 999. So I'm going to do normal CDF, 200 to 999, and then the 173 and 31. I'm always going to write down what I put in my calculator so I know if I did it right or not. Plus it tells me that if I get it wrong, what I put in, so I know I put the right things in. So 200 to 999, and we just use 999 because we can't put infinity in, so this way the calculator just takes it as a big value. So 0.192 or 19.2%. Less than 114 feet. So if this is 114 feet and we're going less than, then we got to go from negative 999 to 114. So we're going to normal CDF, negative 999 to 114, 173 to 31. So second, negative 999 to 114. And so we get 0.029 or 2.9%. Okay. Number 4, a group of jockeys were weighed and was determined that their mean weight was 112 with a standard deviation of 4.2. Miguel Cabrera weighed 118, and it says what percentile, that's percentile, was he in? So we want the percentile, so that's a normal CDF. Now, he's weighing 118 pounds, so we're going up to his amount. So we're going to go from the bottom up to his amount to know what percentile he's in. And then the 112 and the 4.2, because that's our new weight and standard deviation. So normal distribution, negative 999, 118, 112, 4.2. So he's in the 0.92. So this jockey is a big old boy for jockeys because he's in the 92.3 percentile, right? Y'all know what jockeys are, right? The guys that ride horses. Okay, it says Oscar Salazar was the 50th percentile. So we know the percentage point. We want to go the other way. So if we already know the percentage, we want to do the inverse normal, okay? So inverse normal, we put the percentage in first. That's the area, the percent, the whatever, okay? If I want to know a z-score, remember z's go 0, 1, 2, 3. So the z-score, we put 0 for the mean and 1 for the standard deviation. All right? So if I do the inverse norm right here, number 3, the area, that's telling me what percentage do I want. I want the 50th percentile. And this is a mean of 0 and a standard deviation of 1. That'll give me just z-scores here. And it says that my z is, I don't know why I hit this that many times, is 0. Well, does that make sense? That is 0. Well, let's think about this. If I have, here's my normal curve. Here's my mean, right? And it is 0, and this is 1, and this is 2, and this is negative 1, and this is negative 2. Is 50% of my data down here and 50% up here? Well, yes, it is. 50% is at 0. That is my z-score here. So now if I just wanted to know his weight, I would inverse norm the 50th percentile. And now because I want an actual number, I put in the actual numbers. I put in the 170, 112 and 4.2. Now you should know what the answer is here because his z-score is 0 and his weight's at 50%. So hopefully you already know what it is. Well, if you don't, I'm going to tell you. It should be 112 because that's its mean. The mean is 0. That's a z-score of 0. But we can put it in our calculator and check. So inverse norm. And now if I put the values in here of 112 and 4.2, should tell me that it's 112. Okay? Now, the last part says James Doyle was in the 74th percentile, so that's the 74th percentile. So we're doing inverse norm again. What did he weigh? So because we want to know an actual value, we're going to do 112 and 4.2. So inverse norm. He's in the 74th percentile. So he weighs 114.7 pounds. If I want to know his z-score, I would inverse norm that 0.74 and I would 0.1 it. So 0.64 would be a Z. Now, look at your homework real quick. On this one, problem number 1, it says find the Z-scores here, right? And remember, to find the Z-score, you do X minus X bar divided by standard deviation. Well, what they've done is they've already done the X minus X bar here. So they've already done the X minus X bar. They told you that it's 20 points above the mean, and they told you the standard deviation is 10. So that's all they're doing. Here, it's 10 points below, so that's negative 10 over 10. So that's what you would do up here, okay? Then when you get down to question number 4, remember I told you that norms come from the bottom. So if I was doing the highest 30% here, I would need this portion here. So that's 70%. So I would need to inverse norm 70%. And I just want the Z-score, so I'm going to go from 0 to 1. So this one says lowest, that one would be okay. And the highest 75%, I've got to do this same thing that I did here. Okay. Let's look at 5, 6, and 7. And I think you can figure out the rest here. Oh, number 3, I missed a sentence here. Number 3B should say find the Z-scores. So you're just going to find the Z-scores for 372 and 628. Number 5 says find the area, that's the percent, between the mean and the Z-score. Well, in this case, we're talking about the mean being 0. So that means one of these is going to be the lower and one of these is going to be the upper, okay? So obviously 0 is the lower here and the upper is 1.17. But when we do it this way, 0 is the upper and negative 1.37 is the lower. So you're going to normal CDF these because you're finding the percents, right? This one says find the percent. And this says of the individual scoring below. So if we're scoring below, we're going to do negative 999 to this value. And in number 7, it says scoring above this number. So you're going to go 2999 on these. I think the rest of them are fairly simple. Those were a little bit weird, so I wanted to talk about those with you. So that should be all you need to do your homework for Z-scores.